First of all, thank you very much for attending our Global Energy Trends webinar, which is an exercise that we do every year, mostly to present the consolidated figures for the past year, so for 2024, and to try to draw conclusions from that. I'm not going to spoil anything from what we've observed. Let's say that the message we have the impression of repeating ourselves a little bit, but we'll get deeper into that in the next slides. So first of all, a few words. I'm not going to be too long on this, hopefully, on Enerdata. So we are, for those who don't know us, an independent energy research and consulting company with 30 years of experience. We are located in France, in Grenoble, in the French Alps, but we have a global outreach to clients and partners and topics that we cover. Basically, at Enerdata, we are combining so an expertise, first of all, in energy market, climate, with modeling tools, especially to try to use perspective analysis and how the energy systems are going to evolve, with a lot of data science and data analysis, namely to produce a lot of databases on energy consumption, energy supply, energy infrastructure, etc. And also market intelligence, a lot of different products and projects on basically trying to be on top of the issues that energy markets and clients are dealing with. So today, Géraldine and I are going to be the speakers. So Géraldine is a senior analyst at Enerdata. She's been here for a long time, and she's used to this exercise. And I'm also used to accompanying you in this exercise. So Géraldine is first going to present the figures for 2024 and also the recent trends in general. And I'll try to bring a little bit of perspective, looking at how does that compare to pathways that are compatible with the climate objectives that we have, and also do a little bit of a focus specifically on Europe, looking at what happened over the past years in Europe and why it happened more specifically. So these are basically the four main sections that we are going to cover. So an overall analysis of key energy and climate figures, trends by different types of energy, comparing these trends with decarbonisation pathways, and then this focus on Europe, looking at how the emissions and the energy consumption has evolved recently and what were the drivers behind that. We're going to take, I don't know, 10, 15 minutes at the end for questions. You have a specific Q&A box that you can use to write your questions, and we'll try to address as many of them as possible. So don't hesitate to start filling the box. Every time something pops up and you need some kind of question, you need some further explanation. All right, so without further ado, I'll leave the floor to Géraldine for part one of this presentation.
Hello, thank you. So I will present to you the main climate figure, energy and climate figure for 2024. So with 5 indicators and 3 really important ones. So the key figures would be 3, 2, 1. So 3% is the economic growth in the G20 country. It's almost in line with the long-term period. So in this presentation, we are talking about long-term, the 2010-2019 period. So before the COVID crisis and after the rebound. So it's 3%, it's back to normal for the economic growth in the G20. 2% is the energy consumption growth in the G20. It's slower than in 2023, but much faster than over the long-term trend. So there is no slowdown in energy consumption. 1% is the average growth in CO2 emissions in the G20. It's a new growth, again, despite targets, despite policies. It's in line with the long-term trend, so there is no real improvement. So we will see which are the factors that have driven this increase. Two complementary indicators, final energy intensity, which is the final energy consumption compared to GDP. So how much you need to consume energy to produce 1 unit of GDP, which is declining very slowly by less than 1%. This is slower than over the long-term period. And the carbon factor, which is the CO2 content of the energy you consume, which is declining very slowly by less than 1% per year, the same rate as over 2010, 2019. So no big improvements in the recent years. So let's see economic growth first. Okay, so let's have a focus on economic growth, which is one of the main drivers for energy consumption and CO2 emissions. So on average, the G20 economy grew by 3%, so the same growth rate as in the previous years. It was driven by non-OECD countries, which now account for half of the global wealth. The 5% growth was led by China, which alone accounts for 1/4 of the G20 GDP.
Describe the graph beforehand. So
yes,
sorry.
Yeah, sorry. So our graphs are the same for almost all indicators. You have in orange the 2024 growth rate, in blue the 2023 growth rate, and in green the long-term growth rate per year. So you can see the different trends between the years. And the line below is the share of each country or each zone in the G20. So you can see that China accounts for 25% of the G20 GDP. So we don't represent all the countries, but the most significant for each indicator. So for China, it was a 5% growth in 2024, like the year before, a slowdown compared to the long-term period because China is still hit by the lingering effects of the real estate crisis, which has negative impacts on its consumer confidence, consumption, but still 5% is a strong economic growth. It was also very dynamic in India, in Indonesia, in Russia, despite the economic sanctions, because of steady investments in the military and industrial complex. Whereas in OECD countries, the growth was slower. It was about less than 2% in 2024, 3% in the US, but in other countries, in all OECD countries, the economic growth was slower, just 1% in the EU, a stagnation in Germany. In Japan, after the growth years, the rebound years after the COVID-19 period, economy stalled. So this economic growth will be the main driver for energy consumption. So as for economic growth, the growth was led by non-OECD countries, which account for 60% of energy consumption in the G20. So China, again, was the main driver. China accounts for more than 1/3 of the G20 primary energy consumption. So that's all energy included, including energy used in the power sector, in refineries, in gas liquefaction units. So China is about 35% of the total consumption. This is twice as much as the US, and it's the main driver for global energy consumption. It slowed down compared to the year before, but still is increasing at a rapid rate. In India too, there was a slight slowdown, but still a 5% increase in consumption. India now accounts for 10% of the G20 energy consumption. This is as much as the EU. So as for economic growth, the growth in energy consumption was led by non-OECD countries, whereas it was very slower. It was much slower in the US, in the EU, and Japan, even declining in Japan. So
Skip forward.
no, it's okay. So the final energy intensity here is the final energy consumption compared to the GDP. So here we don't take into account energy consumed in power plants or refineries, only the final energy consumption from sectors, from industry, from households, from the transport sector. So we can see that we had a broad improvement over the long-term period with about 2% per year decrease since 2010. But in recent years, the improvements have been slower. So the trends are different if we compare OECD countries and non-OECD countries. The improvements are led by lower energy consumption in OECD countries, by strong economic growth in non-OECD countries. And the improvement is slow and it's not enough to meet the 2-degree pathway. The decrease, excuse me. The decrease we should reach to meet the 2-degree pathway. So let's see CO2 emissions. They grew by 1% in 2024. China and India were the main drivers for this growth. These two countries account for half of the G20 emissions. There was a slowdown compared to 2023 due to renewable power generation, which contributed to slow down thermal power generation and then CO2 emissions. But still, these two countries were the main drivers for the growth in CO2 emissions in the world. CO2 emissions also increased in Indonesia, which is only 3% of the G20 emission, but still it's increasing very rapidly due to the strong weight of coal in these three economies. In OECD economies, the emission declined, but at a slow rate by less than 1%. So this is a continuous decline in OECD countries due to coal phase-out policies, higher renewable power generation, but still insufficient to meet the 2-degree pathway. So that's the second graph you can see on the top right. With the trend since the Paris Agreement, with emissions continuing to increase, whereas we should be cutting them in a very strong way. So the slope to reach this 2-degree pathway is increasingly hard to reach. So this decline in CO2 emissions is not enough, and the carbon factor, which is the carbon content of the energy we consume, is declining at a very slow rate by less than 1%, around 0.5%. So with different trends in OECD and non-OECD countries, this is due to the share of fossil fuels that remain very significant. So fossil fuels still account for 80% of the G20 energy mix, for about 60% of the power generation. So even if renewable power generation continues to increase, carbon factor remains very, very high and doesn't decline enough to meet the 2-degree pathway. So that's far from the 3% per year decrease that we should have to meet this target. So in a few words, we can reach back to its normal 3% per year average. Energy demand continues to rise at a faster rate than over the long-term period. So we are far from a gradual decoupling trajectory. We need to reduce energy intensity and the carbon factor to meet this target, to help the global economy to reach this pathway. So of course, there are very huge differences between OECD countries, so China, India, Indonesia, and non-OECD countries. So the new increase in CO2 emission, though at a slower rate than over the recent years, is not sufficient to meet this target. So let's have a focus on each energy. So in this slide, you can see all the trends for each energy. So the 3% economic growth translated into a 2% increase in energy consumption, a faster rate than over the long-term period. So in 2024, all energy consumption increased except for oil, which declined by 0.6% compared to 1% average growth over the long-term period. So this 0.6% decline, it's more or less a stagnation. It's due to a slowdown in the US and a slight decrease in China, so we'll see it later. But on the contrary, electricity consumption grew by nearly 4%, much faster than over the long-term period, which contributed to raise coal and gas consumption by 2 and 3%, which is much faster than over the long-term period. So coal consumption continues to rise. It's driven by non-OECD countries, which account for nearly 90% of of coal consumption, especially China and India, which control 3/4 of the G20 coal consumption. So the coal consumption was driven by Asian coal producers such as China, plus 3%, India, plus 5%, and Indonesia, plus 12%, despite a higher renewable power generation in China and India. So in those two countries, there was slowdown, but still very strong growth rates. On the contrary, coal consumption continued to decline in OECD countries due to coal phase-out policies and higher renewable power generation. So with strong declines in the US and the EU, in stagnation in Japan. Where oil is concerned, there was a slight decline in 2024, less than 1%. This is due to the two largest oil markets, so China and the US with 23% each. So in the US, there was a slight growth, just 1% compared to much higher growth in 2023 due to lower traffic, but a higher demand from the petrochemical sector. In China, the 0.6% drop in China is due to more a correction, a stagnation after the 11% growth posted in 2023. So in 2023, China lifted all restriction on transport after the end of COVID-19 crisis. So there was a huge growth in road transport, air transport in China. So in 2024, it was just back to normal consumption. On the other hand, oil consumption continued to decline in the EU and Japan, just like over the long term. So as you can see on the second graph, primary oil consumption is driven by non-OECD countries, especially China and India. So for gas, there was a 3% increase in 2024. This is much faster than over the long-term period. Again, it was led by non-OECD countries, especially Russia, which was using whose gas production grew by 7% in 2024. So its gas consumption grew accordingly. China and India continue to invest in gas-fired power plants. So these countries contributed to the growth in gas consumption. There was also a growth in the United States as a backup for renewable power generation due to steady growth in gas production in the US. Whereas it was rather stable in the EU and in Japan. So electricity grew by 4%, by nearly 4%. This is much higher than the 2.5% per year increase over the long-term period. Again, it was due to two markets. So China accounted for two-thirds of the increase in the G20. In China and the US, the two largest electricity consumers, the growth was due to the same factor, the same drivers, higher demand from industry, from data centers, from cooling, and from electric vehicle charging. So these four drivers contributed to the strong growth in China and in the US. There was also a strong growth in India, in Brazil, in Indonesia, a higher electricity consumption in the EU, whereas it remains stable in Japan. So a strong growth in electricity consumption, which may be a driver for decarbonisation, but still the share of electricity in final energy consumption is growing, but at a slow pace. It grew from about 17% in 2000 to 23% in 2024. So it's a regular growth, but it could be faster. So how is this electricity produced? Let's have a focus on the power mix. So in 2024, there was a new increase in thermal power generation. So the share of coal remains significant. So coal, gas, and oil now account for about 60% or just less than 60% of the G20 power mix. Thermal power generation continues to increase by 1%. It's much lower than renewable, which grew by 29% for solar and by 8% for wind, but still thermal power generation is increasing. So wind now accounts for 9% of the power mix and solar for 7%. So you have 60% thermal, 30% all renewables, including hydropower, and about 10% nuclear. Okay.
To present this one. That's a duplicate, is it?
It's a duplicate.
Okay, let's
Sorry.
switch to the next one.
Sorry. So let's have a touch of hope with the growth in wind and solar generation. So where wind capacity is concerned, installation were steady with more than 100 gigawatts installed last year. So it was a slight slowdown compared to 2023, but still a very dynamic growth led by China, the EU, the US, and India. So China was the main driver, accounting with almost 80 gigawatts installed. That's 3/4 of the total capacity installed in the G20. So this steady growth in China led to a surge in the wind power generation in the G20, plus 8%. And China now accounts for 41% of the G20 wind power generation. So we have 40% China, 20% the EU, 20% the US, and 20% the rest of the G20. So China produces as much wind power as the EU and the US together. That's the same for solar installations. For solar installations, they grew at very fast pace by more than 400 gigawatts. China was the main driver with nearly 280 gigawatts installed. That's nearly 70% of the total installation in G20, followed by the EU, the US. There was a slight slowdown in the EU, but still 38 gigawatts installed. 25 gigawatts installed in India. So we have concentration in a few markets, with China accounting for most of it. So there was a strong growth in solar power generation in China, in the US, in the EU. Now China accounts for 44% of the total solar power generation. This is as much as the EU, the US, India, and Japan together. So China is really the driver for installations and for power generation. It doubled its solar capacity in 2 years and now accounts for half of the G20 solar capacity. So that was the touch of hope. And
yes,
we can see if we are in line with the decarbonisation pathways.
Yes, and I'm not going to give the answer just yet, but I think you might have a clue of how we're doing compared to where we should be. Yeah, so just as a reminder, I've seen that a couple of people have used the Q&A box already. So I don't know if you can find it on the Zoom menu. It is there somewhere, it should be. So don't hesitate to use that to start writing the question again. And the first questions are questions that we used to have, but I still don't manage to tell it beforehand. You will be sent the slides. That's the typical question, and yet I failed to mention that at the beginning of the presentation. You will get the slides that are shown today, so don't worry. So now I'm going to, as it's been already said, try to look at what happened, what basically Geraldine has already presented, and put that in a perspective of where we should be, or at least where we are projected to be, if we were to be aligned with our objectives in terms of reducing the GHG emissions and try to mitigate the increase in global temperature. So for that, I'm going to use the inner future scenarios, which are scenarios that we are developing here at Enerdata and that we are updating every year. It's basically our vision of the future of global energy systems, but split into three different basically trajectories, three different scenarios. And these scenarios are basically differentiated by level of ambition in terms of the policies that are assumed with regards to mitigating GHG emissions within the energy system. So the first scenario is Enerdata, which is basically a baseline scenario. I'm not going to spend too much time or even, I think, showing the results of Enerdata. It's basically a continuation of policies and trends that's, basically a continuation of existing trends and including policies that have already been implemented, but no further policies to reduce GHG emissions and energy consumption, etc. Then there are two scenarios with different degrees of ambition. There's the Enerblue scenario, which is basically aligned with, it considers basically that all countries are respecting their pledge, like they are achieving their NDCs that have been submitted up to the end of 2024, which was the last update of the scenarios. And then there's the Green scenario, which is basically, well, the underlying objective of the NDCs, which is to try to maintain or mitigate the increase in temperature well below 2 degrees Celsius. So first of all, you see that these two are different. So basically, the NDCs are not sufficient to reach the objective, the underlying global objective of the NDCs. Green is more of a backcasting scenario where we say we're going to reduce the emission as much as possible in order to try not to stay below well below +2 degrees in temperature. And the NDCs are not. So there's the question of aligning with the NDCs, and then even if you do that, it might not be enough to respect our targets. The scenarios are based on our world globally recognized polls model, polls Enerdata, because we are actually a couple of three different institutions using this model. It's a global energy system model covering 66 different countries and regions. So there's this sort of regional differentiations, which we're definitely using, reduce scenarios that are basically country and region specific, but covering also energy supply, final consumption, energy transformation, electricity production, etc. So this was the definition in a glimpse at what it looks like in terms of results, and compared to the gray line is basically just extrapolating what we've seen since 2015. And then you have the results of the Enerblue and the Energreen scenario. So as said, they are differentiated, right? Energreen goes beyond Enerblue, Enerblue being the NDC scenario, Energreen the well below 2 degree scenario. But in both cases, you need a huge shift compared to what we have been observing lately. So CO2 emissions keep increasing. We need to see a shift, yesterday in terms of CO2 emissions, and we need to see them reducing if we want to align with a trajectory that's compatible with our objectives. Same thing from energy demand. The share of fossil fuels remains very high. It's reducing, but at a very, very slow pace. It's around 80% at the moment, and it needs to drastically cut if you want to achieve our objectives. Now, something that has been interesting to do is looking at Energreen, so this the more ambitious scenario over the years. Firstly, looking at Energreen from 2016, which was around the time of COP21 in Paris, in the Paris Agreement, and then looking at different basically versions of Energreen up until this last 2025 version of Energreen. And interestingly, they sort of converge in 2030, which is not by construction. Obviously, Energreen, the new version of Energreen goes way beyond, and we need to cut a lot more emissions after 2030, but the 2030 point seems to converge. And so what we're seeing here is that each year we are pushing back the efforts that we need to implement. The problem is it's not just a matter of starting late. There's a lot of accumulated emissions that have been. If we had implemented the right policies at the time, we would have avoided. And then some people may have seen some reports on the fact that we basically reached our emissions budget that would be compatible with the 1.5 degree increase in global temperature. So basically, what you're seeing here is the volume of emissions that we could have avoided, and also the fact that the slope is getting steeper and steeper. I'm not going to say that it's become unrealistic, but it's definitely become a lot more challenging to align with this scenario. So we would need basically a 5% per year drop between now and 2030, where we've seen that we are going plus 1% in terms of emission, right? So yeah, definitely a huge shift here. Now I'm going to try to sort of split and have a more broader vision of what's going on by selecting specific indicators that already have been introduced by Geraldine. It's not, I mean, it's not perfect, but at least it offers this overview of what's going on in different elements of the basically the energy system in the relation with the relationship with CO2 emissions. So first, we're going to look at the energy intensity. So this is primary intensity, by the way. So I said it has its I mean, it has its downside basically, because primary energy reduces as renewables gain in weight in energy consumption, because by convention the efficiency of renewables is 1. So basically there's this sort of bias, but at least primary energy also allows to take into account energy consumption in energy transformation, for example, power generation, that sort of thing. So I still think it's relevant, but it needs to be taken into account. Then the carbon factor, so the amount of emissions by unit of energy. And then we look at it's basically the growth rate of the share of electricity in final consumption on the one hand, and the growth rate of the share of renewables in electricity generation on the other hand. So what we're seeing is for G20 countries, we kept the same scope as what we've been presenting so far. And we see that we're basically far from what we would need. So if we look at 2015 to 2024, we are very far from what we would need now from 2023 to 2050 to match our objectives. So energy intensity has declined, but not enough. Carbon factor has barely declined for G20 countries as a whole. Electricity has not gained enough weight. So we've seen that we had a plus 4%, but this could also be due to not really structural reasons. This not, for example, that there's been a lot of cooling in China and the US to explain what was going on overall, and especially in developed economies. The share of electricity has not really increased that much, despite it being a pillar of the strategy to decarbonize energy systems. Renewables, this is where basically the increase has been the more significant. Still, it's not enough compared to what we would see in the future. Now, this is just to show same results but for different countries and regions. And basically the observation is similar, more or less. So a little bit of energy intensity decrease, but not enough. Carbon factor has barely moved over that period, especially if you look at the EU and the US. Well, it's really not significant. Electricity, the share of electricity in final consumption has barely increased. We've said that in the EU and the US, not as much. In China, it's been again more noticeable, but also not enough. If we're using this benchmark, like looking at what we need to see now. Renewables, again, it's the most significant indicator in terms of what has been going on. So there seems to have been a good dynamic on renewables. It's still not enough. If you look at the EU, it's actually aligned, right? We're at around 5%. We started with a higher share of in electricity generation to begin with, but overall the observation is the same if you look at regions. I'm just looking at the time to see how much time we have. I think we will have a 15-minute Q&A after that. There's still a section on Europe that I want to show. So basically, what we are taking away from this is that energy consumption is growing at a faster rate than the energy prices. So that's worrying. We are not really seeing. We are seeing some decoupling, right, between GDP and energy consumption on the one hand, and between, let's say, even to a lesser extent, between energy consumption and CO2 emissions, but not at a significant enough level. What is really worrying, if you look at the graph with the different versions of our green scenario, is that each year takes us further away from our objective. It becomes more and more challenging, and we have this emissions that are emitted that are basically adding every year, and that we need to compensate for in the future. The dynamics vary across G20 regions. There's really this, for developed economies, it's not really the same as for emerging economies, where obviously there are economic and demographic factors that are driving the energy consumption and emissions of both. That's very clear. But if you take that into account, and if you look at indicators that are relative to GDP, for example, you don't see really developed economies doing that much better than. Renewables continue their expansion, and that's great, but at an insufficient rate. And also, in the meantime, there is no real electrification. That's where the potential for renewables and for decarbonization lies. It's electricity. So it's great. We are definitely increasing the share of renewables in electricity generation, but the impact is limited because there's no electrification, basically. And what we're seeing, because there's no electrification, is that the consumption of fossil fuels continues to grow. That's really, really worrying. Basically, there are more renewables, but they seem to be adding on top of fossil fuels rather than really replacing them, essentially. So now, after a sip of water, if you don't mind, I'm going to look with sort of a different methodology, but more specifically at what happened in the European Union in terms of CO2 emissions, and then looking at what were the sectoral specific drivers behind that. So basically, the first observation is that emissions are down by 2% per year in the EU. It has mostly been happening on, so I've sort of spoiled the analysis because there's a lot of things that I've said before that's true for G20, that it's going to be even more remarkable for the EU, but it's definitely mostly from the power sector, right? So the emissions from the power sector are reduced by 6% per year since 2015, and final consumption only by 1% per year, but it's still a significant. This is in the context of, and we'll get to that looking at the sectors, low economic and demographic growth, right? So now let's look at the different sectors and what we were able to observe. So there's a little bit of an animation here. Basically, we see that since 2022, there's been a decline in industrial activity by around 5%. This is basically an activity index of all manufacturing industry. But if you look more specifically at sectors that, and this is so metals, chemicals, and non-metallic minerals, so sectors, branches that are particularly intensive in terms of energy consumption, they have been dropping a little bit more significant. So basically, because of the energy crisis, the EU has been more affected by rising energy prices, and so these sectors in particular have been decreasing a little bit more. So basically, if you look at manufacturing industry as a whole, it has declined. If you, and this is the dotted line, basically, if you take into account the share of energy-intensive branches, it's even more noticeable. And especially, it is noticeable since 2021. So there's definitely, and I think that explains most of the reduction in CO2 emissions in industry. There's a decline in activity. Now, there's also, in the meantime, energy efficiency and some very, very marginal electrification, but it's mostly because of the lack of problem in competitiveness, basically, of the European industry, which is worrying, obviously, because we want to see CO2 emissions go down, but not at the detriment of economic activity in the industry. Now, looking at households, so this is the waterfall basically explaining how we went from the level in 2019, so pre-COVID, to 2024 with the different drivers that we were able to isolate. This is a methodology that is inspired by the Odyssey project. We can refer to that. So basically, emissions have decreased by 11% since 2019, and there's a lot of different elements. First of all, activity. What we call activity is overall population, dwellings, services, the equipment, the amount of equipment that households are basically increased. So there's an increasing effect because of activity, and it's been more than compensated by other factors. Energy efficiency, so appliances, renovation as well, has been pretty significant. We even isolated as much as we could the role of heat pumps. Our conclusion is that although they are emerging, they only account for around 8% of residential space heating. and sales have started to decline, which is a bit problematic. So even though there's a dynamic over the last few years, it's not yet a huge driver in reducing emissions. Overall, electricity has only gained 1.5% percentage points since 2019. So electricity has not been a major driver here. There's a little bit of a climate effect between 2019 and 2024. Basically, winters are milder, which is going to be a factor in reducing consumption of space heating. And then there's a residual component that we are not identifying with the other drivers, which we can associate to behaviors, basically. At least this is our assumption. And obviously, these behaviors have been influenced by energy prices, which has been quite high. So it's not something that we necessarily want. that is just basically precarity in terms of energy consumption. But it's quite hard to obviously decipher. But in the middle of that, there could be structural behavioral components that we can build on to better basically consume energy in the residential sector. But it's not a huge element. Now, in the transport sector, emissions have been more or less stabilizing. It's quite interesting to see that it's mostly from traffic, from what I could gather, meaning that traffic has not really recovered its pre-COVID level. So that's interesting, especially passenger traffic. Goods traffic is relatively stable. So there's some, again, behavior, new habits, maybe a lot more working from home and that sort of things. And so there's a little bit less traffic. And even though it has rebounded after the pandemic, it has not recovered its pre-COVID level. But I don't see any other. This is the most significant driver, would be my. Obviously, there's a huge dynamic in terms of electric vehicles. But electric vehicles, if you look at the graph on the right, it has been increasing quite significantly in terms of sales. In terms of stock, it's still quite low. It also started to decline in 2024, according to our estimations, which again it's a bit worrying to see that sort of shift in dynamic. And overall, this is only so electric vehicles mostly affect passenger light vehicles. So ultimately, that's not a huge part of it's a very small part actually of energy consumption in transport. Electricity only represents 2% of total energy from transport, and it's still mainly from rail transport rather than electric vehicles and light vehicles. So basically, traffic is the main explanation in stabilization of emissions post-COVID. The share of oil products overall has not been decreasing. It's the same since 2010. And we don't see any modal shifts, right? The share of road transport in passenger transport is also the same since 2010. And there's even been an increase in the share of transport, trade transport. Now, looking at again, to end with positive notes, even though it needs to be nuanced, there's been really a huge decarbonization of power generation. And again, if you look at a waterfall of the explanations why it has decreased, it's overwhelmingly because of substitution to carbon-free sources, right? Renewables or nuclear, right? There's been a little bit of fuel substitution between fossil fuels, from coal to natural gas, but it's quite small, looking at least at the sample between 2019 and 2024. Electricity consumption has also decreased, as we said. So electricity consumption decrease is a factor in reducing CO2 emissions. Again, this is really problematic in the sense that the whole point of decarbonizing the power sector, or at least in a consistent strategy to decarbonize energy systems, we need to see power generation being decarbonized while electricity gaining weight in final energy consumption. So renewables replacing fossil fuels in power generation, and electricity replacing, really in a simplified way, to electricity replacing fossil fuels in final demand sectors. And this is not what we're seeing. So we were able to reduce significantly the carbon factor in the power generation. There's almost 50% of renewables in 2024, but the impact of that is limited in the context of the absence of electrification of it. So I'm going to repeat myself a little bit, and then we can switch to the questions if there are any. So basically, the recent decrease in emissions in the EU, I would say, is due in large part to the economic and demographic context, right? We are not, again, contrary to emerging economies, there's no driver because of increasing population, access to energy, and that sort of things that is driving energy consumption. So we have this benefit in a way of not having this driver. And also we are seeing this sort of stagnation or decline in more recently of European industry, which is worrying us. We are seeing low emission and energy efficient technologies emerging, but the pace is not high enough. And a good example of that is the decarbonisation of power generation. It's been really significant, but in the absence of electrification, the impact is rather limited. If you look at specific technologies that are really put forward as applications that are actually both decarbonized and energy efficient, such as EVs and heat pumps, they're still really niche applications. They're not taking over. Like there's a huge dynamic, but they're not taking over. And actually, they're also starting to show signs of slowing down. There's seems to be positive changes in behaviors. I mean, again, in households, it's hard to say exactly if it's just a result of price elasticity basically, and increased very high energy prices that have pushed consumers to reduce their energy consumption to the detriment of their comfort, or if it's just good habits that are starting to take place. In passenger traffic as well, it seems to be that we have not recovered completely the level of traffic that we had. If we manage to build on that and couple that with meaningful measures to decarbonize transportation, we could see at least the beginning of the shift. So this is all for this presentation. I will now leave it to you to ask me a question. I don't know if there are already some questions that we could address. Let me see.
I started answering questions.
Okay.
You can have a look. Maybe you will have more insights.
Okay, let me see. I cannot find my. Okay, let's go. So I'm going to read a couple. So there's a question saying it seems that electrification of end users is what needs to be picked up, which end users must become priority for electrification. So I don't know if there's necessarily a priority here, and it needs to be across the energy system. As we said, there seems to be like this focus on heat pumps and electric vehicles, which I think is definitely key technologies because they allow not only to decarbonize space heating on the one hand and passenger transport on the other hand, but they also present huge gains in terms of energy intensity, energy efficiency compared to conventional solutions. So I would say these two, and also this application for electricity in freight transport or trucks, basically, I think is going to be key to decarbonize the transport sector. And in the same way, there are also applications for heat pumps in certain, so at least medium temperature applications in industry that could prove, that could help decarbonize the industry. So yeah, I'll stick to that because I see that the questions are coming up. So, do you model the municipality scale decarbonization pathways along with the country scale? No, unfortunately, we mostly have a national approach, both in terms of the data that we collect and the model that we're using. So basically, the trade-off is, I mean, we have a global scope, which is great, but we don't really have a detailed vision of that, at least no real regional granularity. I'm not sure I'm going to be able to address geopolitical questions, but I see that if you consider the latest war situation across countries, can you talk a bit about the impact following in short term and midterm? Yeah, I think I'm not gonna address that. This is really something that we need now to take into account as much as possible in the production of our scenarios, but we're not really geopolitical experts, or at least enough to address that, and we mostly rely on other people to do this sort of work and to try to integrate their conclusions. So what can be the key drivers enabling the shift towards electrification? So I've talked about like different technologies and applications. I do think there needs to be some incentives to promote that. So we've seen that there's been a lot of incentives to promote, and this works to a great extent, renewables in electricity generation. There needs to be similar incentives, basically. I mean, I'm not going to discuss exact policies, but I think in general there's a lacking support for electricity-based solutions. That is yeah, problematic. So let me try to scroll down a little bit. Before I answer on the questions. So yes, you will get the slides. I see that there's another question related to that. So there's some questions about specific technologies or specific energies and their contribution to long-term energy scenarios. I don't know if there's a question that inspires you, Geraldine, as well. I think, I mean, this is general. There's a question about the role of bioenergy. There's definitely a contribution of bioenergy. I mean, in our model, this really, we really try to activate all the levers that we can to reach, you know, results in terms of decarbonisation of the energy system. The role of bioenergy would be less significant than electricity, for example, in our scenarios. At least that's the case. Also true for hydrogen. It's a lot of hype around hydrogen. Not as much lately, but we really on the conservative side in terms of hydrogen. And I guess electricity would be the main decarbonization driver, but also alongside reducing energy demand, whether it is due to energy efficiency or sufficiency measures, behavioral measures. We really have a huge emphasis on this lever rather than being overly focused on technologies in our approach. There's a question on battery storage. This is sort of a limitation of our analysis. Again, I was speaking about the lack of you know, spatial granularity in our model. So that's not something, again, something that we mostly rely on others to feed us input to take into account. There's a question on how much time do we have left. So let me take a few left. There's a question on yeah, so okay, I'm going to take these ones. I think there's a question on nuclear power. So, I mean, here we are in France, and a lot of the topic around energy transition has been concentrated on this renewable versus nuclear power. I think it has a role, and I think we're not the only ones saying it. I think there's a consensus that basically nuclear is going to remain, in terms of share of electricity generation. I would say it's not going to be a huge shift. But this means that because we are tabling on almost doubling the electricity consumption by 2050, this means that in terms of volume, there's going to be a lot of nuclear plants installed over the world. That's what we're targeting, and that's what I think most comparable energy perspective scenarios are targeting as well. But it's not really going to take over. I don't think there's any scenarios that are planning on that. But still, there's definitely a future for nuclear, but it's not going to take over electricity generation. Really no one agrees on that. No one is saying that. The USA is out of Paris Agreement. How will this affect your scenarios? So basically, there are scenarios. So we're not trying to forecast what is going to happen. Obviously, for the sake of being realistic, we're going to have to integrate that into the next update of our scenarios. But at this point, it's really a work of what would happen if we meet our target. I think this is why Green is also very important. So this is what we call a backcasting scenario. We have an objective. How do we reach it? In terms of the sets of policies that we need, the technologies that we want to see appear in our scenarios, but also the distribution of the efforts between the different countries, which is based on a methodology that we basically developed more or less in-house with the help of experts that we used to work with. So possibly the Blue scenario is going to be implemented, and you're going to see a huge gap between the Blue and the Green scenario when the USA is concerned. But globally, it's not going to change much. We're going to have Green, at least, it's not going to change much. And I think this is the most important scenario, to show the way to decarbonize as much as possible, even though it becomes unrealistic. Not necessarily unrealistic, but it becomes more and more challenging as efforts keep being pushed back. We still believe in the usefulness of producing such scenarios, because just because we're seeing this objective in particular becoming more and more challenging doesn't mean we have to stop trying. Basically, it's become even more important to continue to mitigate as much and to reduce CO2 emissions. All right, I see that it's starting to slow down. Some questions. How much time do we have? So there's a question on the use of waste as an energy resource for generating electricity. I think more or less I gave an answer for bioenergy. I would say I would give a similar answer for waste. It's going to play a role, not necessarily a huge role, but again, we try to have a panel of different options that are in a coherent mix in terms of these options. There's a question on the inputs that we're using for our models. So we have the chance of both having modeling tools and a huge amount of databases on energy supply, demand, and infrastructure. So basically, one feeds into the other. But still, there's still some challenging, and I mean, this is not specific to that. We've shown the results for 2024. There's been a lot of work. This is why we're presenting 2024 results in end of June. It's because it's a lot of work to try and reconcile sometimes contradictory figures, wait for national statistics to publish, try to benchmark them against what others are doing to try to make them make sense. Sometimes it could be a bit challenging. There are errors, there are different standards in terms of collecting energy. So yeah, the data part of it is problematic, and I think it becomes even more problematic if you go into, again, we talked about like a more regional and a higher spatial resolution. Looking at it from a national perspective is easier, but it has obviously its limitations.